What's going on, everyone? Welcome back to another episode of the Muscle Memoirs Podcast. We have a terrific episode for you today. Joined with me is Dr. Chad Kerksick. Dr. Kerksick, how are you doing?
Man, I'm doing really well. Excited to be here. Thanks so much for having me. This is going to be a fun little talk.
Absolutely, and thank you so much for joining me. We have a recent review paper of yours to dive into, but before we do so, could you give the listeners a little background about yourself for those who might not be familiar with you and your work?
Yeah, of course. So thanks for that. So currently I'm an associate professor and assistant dean at Lindenwood University, which is located in St. Charles, Missouri, so kind of a northwest suburb of St. Louis. I'm kind of born and raised in this area. Bachelor's, master's, and PhD. I love to tell people that all of my degrees have the word exercise in them. So I've been an exercise nut from the get-go, and then really fortunate to work with people like Dr. Rick Kreider throughout my master's and PhD, Darren Willoughby throughout my PhD, and been a faculty member at University of Oklahoma, University of New Mexico, and then I got two young girls, and we wanted to get them closer to grandma and grandpa, so we moved them back here into the St. Louis area. Been here since 2015, so it's been a great support, great research program going here. We're very, very proud of what we built.
Fantastic. Now, the review paper we're going to be diving into today is titled Plant Proteins and Exercise. What role can plant proteins have in promoting adaptations to exercise? As we mentioned before we got this thing rolling, plant proteins are an increasingly popular topic, and for very good reason. There are a variety of benefits for consuming plant proteins. However, it's probably a little bit more nuanced when we're discussing serious athletes and those concerned with maximizing their performance and recovery, which sets the stage for our general discussion today. To further provide some background as we get into the weeds here, I think a really good place to start is just talking about how we measure the quality of the protein sources that we're consuming. So could you provide an overview for the listeners?
Yeah, and I think I've not ever really done any direct work where we've kind of measured the different kind of quality indicators, the different approaches that are commonly used. But there are some. So there's a number of other good papers like Dan Moore. If you're interested in the protein side of things, he's done some nice work with kind of one of the techniques and has written some really nice things. Obviously, Stu Phillips has got a large presence in this area as well too. But when we look at quality, I mean, I think across the board, you can find various review articles and a number of tables that will highlight things like protein efficiency ratio, protein efficiency ratios, biological value has been commonly used in the past. But I think, throughout my time as a student and faculty, like PDCAAs, so protein digestibility corrected amino acid score has been one of the primary indicators. So it's an analytical technique, if you will, where people can take different sources of protein and you really come up with a score. And typically the higher the score, the greater the amino acid content is within the different sources of proteins. Digestible indispensable amino acid score has been one that has been used a little bit more as of late. And again, like my work, I haven't really dove in very much upon the shortcomings and the advantages and disadvantages of the different types of markers across the board. But I think when we look at protein quality, those are commonly the ways in which we would try to, if we're going to stack the source, kind of up head to head against each other. Bottom line is that we're really just comparing the amino acid content within the different sources of protein. And if we do that, if you look at these tables, you start to see some nice columns side by side. The part of it that is just always hits home for me, you're generally speaking, if you look at, let's say like animal sources of protein. So, obviously the two milk proteins, milk and whey, and then we've got, beef and chicken and egg and, other forms of dairy and so forth. These sources of proteins typically rank, definitely on the higher end of these scales. And then when you start to plug in different sources of plant proteins, the plant proteins are typically not quite at the level of the different sources of animal proteins. That's not always the case. There are kind of some scenarios where some animal proteins may outscore some plants might kind of start to flirt with the levels. But in general, things like whey and casein are usually kind of up there at a level somewhat kind of on their own, and then the plant sources are a little bit lower in the scale. So you can just use that for whatever it's worth, right? So these are these indicators that are just telling us that per dose, per gram, per whatever, animal sources of protein traditionally have higher amounts of amino acids in them if we compare the plant sources head to head. I think what we'll get into is, well, what does that really mean? Like, what is that? Okay, that's great. Does that mean that, we should never eat these or only eat these because of the amino acid content? And I don't think the answer is just as simple as a yes or no.
Absolutely. And we'll definitely get into what you alluded there. Based on these scores, as you mentioned, more or less based on the quantity of essential amino acids within these protein sources, we see that animal-based proteins tend to have a higher score on these figures that we use. But what are some other factors that might be influencing the quote unquote quality or anabolic potential of these proteins? What are some other differences between animal-based and plant-based proteins here?
Yeah, so I mean, I think, when we start to get into the anabolic potential of different sources of proteins, the conversation usually really quickly shifts to things like, the content of the essential amino acids, the 9 essential amino acids. And then there might be some people that'll kind of throw a nod out to the branched chain amino acids. And then obviously we can't really talk about anabolism without talking about leucine as well. So I think, so that's leucine is somewhat unique in the sense that it's been shown in a number of animal as well as human models to function in a manner where it is responsible for stimulating protein translation or the kind of some of the steps of building a protein itself. So that's where that fact alone has driven a lot of marketing campaigns, have driven a lot of discussions about leucine content and everything else. And quite honestly, some of the original designs of some of these studies that have examined different types of plants has centered upon leucine content. So that's, I think, the amino acid content is one factor. And then if we look at like on the plant side of things, I'm going to talk about them collectively. So people have to understand that certain types of plants aren't going to have certain types of things to certain degrees. But there's a number of other types of nutrients or other aspects to various plant proteins that are kind of been deemed like anti-nutritive factors, that things that actually maybe slow or make it a little bit harder or challenging for the body to get those amino acids into the tissue beds where they need to. So you have those types. We definitely hear about those types of factors being a little bit more prevalent within some different types of plants. And I think it's pretty fascinating where there's been some companies that have tried to take different manufacturing approaches, with whether it's different temperatures or different enzyme exposures to help reduce the influence of these kind of anti nutritive factors. So I think overall, that's an area probably for, kind of more like, like future innovation to where, maybe some of the anabolic potential of a certain plant source right now might be viewed to be moderate and not that attractive. And food industry manufacturing wise could maybe go through, identify some innovation, and they might, 5 years from now, that source of plant protein might be pretty good. I don't know. We'll have to just kind of wait and see. So I think those are some of the, kind of some of the key factors that certainly get into it. I mean, obviously, right, you can't have, if we're talking about anabolism and building muscle, we can't have the discussion without, certainly making sure that we've got an appropriate resistance training stimulus, making sure that we're getting enough calories across the board, to help to just kind of promote that overall environment. We always like to tell people, it's like, it's very caloric expensive to build muscle. Like it takes a lot of energy, it takes a lot of calories to do that. So you need to make sure that you're eating as well. It's not just about stuffing a whole bunch of amino acids on your body. There has to be some other parts of the equation that's in place too. Did I miss anything that you were wanting me to address?
I don't think
No?
so.
Okay, cool.
Yeah, that was excellent. And so we have here, there's these differences in total essential amino acid content, and then we have these specific essential amino acids, maybe BCAAs, more so leucine. We see some key differences. And then we also have to consider things like absorption kinetics, the other things that are going on within this protein that can affect the rate at which we can get this into the tissues that we want it to get to. So as we continue to build the stage here, this brings us to acute studies on the topic, basically comparing two different protein sources, more or less, and evaluating the MPS response. And as we know how critical MPS is for ultimately synthesizing new tissue over time, this is definitely something that's important to talk about. And I think we can start here by at least giving a nice overview of the available data, which compares animal and plant-based protein sources, but then we can follow with the potential limitations of these acute studies.
Sure, of course. Yeah. So I think, we created a whole separate section within the paper that just kind of highlighted on, the acute studies. And so when we talk about an acute study, we're generally talking about some type of a study design. Many times they're relatively small numbers of populations, small numbers of participants, excuse me. Generally crossover designs, which is certainly a strength to them. And it's usually, one bout of exercise, one dose of supplementation or nutrition. Not always one bout or one dose, but I think a lot of times it's a pretty short-term intervention. And then they're measuring in a very elaborate fashion, the changes in amino acids within the blood and within the muscle. From the scientist side of me, I always think it's so important for listeners to understand, like, these studies are not easy to do. They are unbelievably complex. You need impressive arrays of equipment, as well as very high level, research staff and medical staff surrounding you to make sure that they're done safely. They're very expensive to run. I mean, they are very expensive to run. I mean, a lot of times it's like an automobile per participant. I mean, because of the isotopes and the time involved and so forth. So I just share that because I think a lot of times it's easy for somebody to look at one of these studies and be like, it only has 8 people in it. Like, well, this is garbage. And you're just like, garbage. Like, this thing just took them 9 months to do. It cost $90,000, to get this done. Like, this is anything but garbage. So that's my defense of the scientists that are out there, because I think that N of 5, N of 6, N of 8 is a low hanging fruit in terms of criticism. Now, these studies in general will give us an idea. When you say MPS, so muscle protein synthesis, there's some really nice, if you read this literature, there's some really nice diagrams that kind of show the general ebb and flow, right, of rates of protein synthesis and protein breakdown across the day. And generally when we eat or particularly when we eat, that balance between protein synthesis and protein breakdown flips in favor of protein synthesis, and we're anabolic at that point. And then if we don't eat anything for 4 hours or so, then a lot of times we kind of start tilting downward, where now we have higher rates of protein breakdown versus protein synthesis. And so that kind of helps feed into this discussion of protein timing and patterns and everything else. But we focus so much on protein synthesis. This is always important for me to grasp. Scientists have determined that about 80% of the overall kind of change within protein metabolism is due to protein synthesis. That's kind of one of the estimates. So that's really why we see so much focus on MPS, because it's explaining a significant proportion of what we're seeing happening overall. Plus, protein breakdown is a lot more complicated to measure accurately and reliably. Now, with that, so these studies are typically comparing, a 25-gram dose of whey isolate to a 25-gram dose of soy, or a 25-gram dose of casein to so we're comparing animals to plants a lot of times. I think, Tang in 2009 in Journal of Applied Physiology probably did one of the most cited classical papers where they compared approximately 25-gram doses of a hydrolyzed whey isolate, micellar casein, and a soy isolate crossover design, and they ingested a single dose at rest, and they measured MPS, and they did it. They ingested a single dose after performing a single bout of lower body resistance exercise, and took biopsies in the legs and so forth, and they found that at rest, the rates of muscle protein synthesis for whey protein were easily the highest. Were higher than the other ones. There was a little bit of separation between the two groups, but then actually when you combined it with exercise, actually the strength or the overall positive favor towards whey was even greater. So that kind of all fed into this discussion of, man, animal whey is king, and it's just look at these MPS rates, and it dwarfs soy, and there really weren't other sources of protein on the market, at least that were at the time. Soy was really about it. So these studies, but since that time, and I think particularly in the last 5 years, we've started to see more studies that have compared animals and some animal source of proteins we've seen studies comparing wheat proteins. I think we've seen oat protein, we've seen peanut protein, we've seen soy. So, and I think in general, Dan Moore does a really nice job of explaining this, in the sense that he kind of takes the approach and opinion, which I really can't disagree with, is like, these studies, just by virtue of the amino acid content, and all you're delivering is just that protein. You're not delivering any fat, any carbohydrate, any other types of things, that go with it. Those studies are positioned very favorably for the whatever source of protein that has the most amino acids to do the best. So, and we do generally kind of see that pattern, across the board. But I think, like in general, when we look at things acutely, if we compare things head to head, there's a number of studies that generally show that animal proteins do a much better job of stimulating higher rates of muscle protein synthesis. And if you just take that and counter that against what I said with, well, why is MPS important and everything else, you can definitely begin to see the beginnings of this discussion, right? That why animal proteins are better, and so forth. Then, so that I think is one way to just kind of talk about the acute proteins in context. I mean, we could get into more of the details of some of the different papers, but I think in general, again, if we compared, in any of these studies that we're comparing, like plant to animal head to head, generally speaking, the animal proteins do pretty good. There were some really important studies. There was one that was done, in an older group of men, and that's a unique population in the sense that as we get older, our muscle gets more resistant to the anabolic properties of different amino acids. So we either need, that's where doing resistance exercise becomes important, because that helps us to kind of maintain a little bit more kind of sensitivity to those nutrients. And then we can, maybe we deliver a little bit bigger dose or whatever else, which could certainly have its own problems and challenges. But this study, they took an older group of men, and I think they delivered, they definitely delivered a 20-gram dose of soy and a 40-gram dose of soy. And they showed that with a 20-gram dose of soy, that did not significantly increase rates of muscle protein synthesis from baseline. So a 20-gram dose did not increase rates of MPS significantly. They did go up, but the changes were not statistically significant. The 40-gram dose did increase that amount. So what does that tell us? Well, I think in an older population, if soy is going to represent the discussion for other sources of plants as well too, because this was just soy, because of the fact that the plant proteins have lower doses of the amino acids, like we already mentioned, in an older population, there's some anti-nutritive factors that may be kind of pulling things back a little bit. That dose of protein, if we want to see that acute increase in MPS, that a higher dose on the plant side might be needed. So I think that was kind of one of the big takeaways as we start to think about, well, how can plant proteins potentially be helpful? How can they potentially be useful? So I think that summarizes a good bit of what we tried to represent on the acute side. Now, you did kind of mention, is there anything along from that else that you would like for me to highlight? I think, because then I think you wanted to kind of get into the limitations of the acute studies.
Yeah, I think that was a fantastic overview, and you touched on some critical points there that we'll definitely get back to. But yeah, from here, I do want to transition to the limitations. Ultimately, we are, continuing to build up this topic, right? And it's like, look, we have these converging lines of evidence where all of these things are kind of pointing in the right direction, where, I think most people would look at these studies, look at the overall body of evidence within this specific area and say, well, it's kind of a done deal. Like, animal proteins are clearly superior to plant-based proteins when it comes to athletes, when it comes to those interested in maximizing muscle hypertrophy, strength, fastness of performance. But we'll get to the long-term studies, because
Sure.
Something I always love to harp on the podcast is that, when it comes to mechanistic research and even these acute studies, right, like, they're informative, and they tell us things that are helpful, and they provide ideas for other research. But ultimately, we need to have some reservations when we don't have long-term trials on humans, seeing if these mechanisms actually pan out into meaningful results. So with that said, yeah, I think this would be a good time to talk about some of those limitations of everything we've discussed so far.
Yeah, and I think just a couple of small little nuggets, of all the different papers that our groups published, outside of the big position stands and these types of review articles that typically, get their own level of attention from the actual original investigations. I mean, the training studies that we've done easily get the most citations. And I think that speaks to the practical relevance, the overall meaning and kind of impact that these types of studies can have. The acute studies absolutely have a role. I mean, like I said, I respect the hell out of these people that do these types of things. I think they're really informative and very interesting to read. It helps guide us into our next steps. And, I think one of the biggest limitations that outside of the advantages that they offer, and I always cite Joey Antonio when I try to describe this. Joey has a very excellent. He's the CEO of ISSN, one of the original founders, and he does a really good job of just saying, the drawing all of your outcomes and influences from an acute study is like driving your car onto a highway, and you get onto the exit ramp, and as soon as you enter the highway, that's going to be indicative of how your travel is going to be down the rest of the road. And I think as you start to paint that picture, people then begin to can start to, I think, understand where to put the acute studies into their proper place, because they're very informative. They're very helpful, but they're, just all we're doing is getting an indication of how that perfect scenario responds within one setting or within one environment. And there's so many factors that can change, that are going to slightly turn that response up or down. And then to what extent they're turned up or down over the course of a week, 2 weeks, 4 weeks, 10 weeks, 6 months will then kind of translate into our overall kind of phenotypical adaptations, which are typically we look at as kind of strength and body composition changes. So I think that's the, it's not a criticism per se. It's more of the fact that people have to have the right context when you're looking at the outcomes. It's like, it is generally not the best approach to take the results of an acute study and say, like, see, this type of protein is better for all people under all scenarios than other people. And I think the way that sometimes some of these things are talked about or communicated, people can certainly kind of draw those outcomes. So I think for the acute studies, they're definitely informing us of how to maybe set up some other studies, and then we've started to get more prolonged studies as well to help kind of give us some idea on how the plant proteins may perform.
I think that was very well said. So let's get into the prolonged studies. And I have two here that I want to get into more detail on. But I think to start, we could provide an overview of generally how these prolonged studies are conducted, and with that, the results that tend to occur. And then we can get into those outliers.
Yep. Of course, yeah. So if you hear one of us scientists say like a training study, or they're talking about, so you're talking about some type of a study that is spanning usually several weeks of training. I think in general, 8 weeks is kind of a very common duration. It's kind of been, but certainly the longer studies are more expensive. They're harder to do. They're harder to maintain compliance. So there's a number of reasons why we don't see a whole lot of 6-month studies. But generally 8 to 12 weeks we see a number of those types of studies. So that's generally what we're talking about. The part of it that really struck me, even as I was putting all the literature together, and I made a point of highlighting it from the very first sentence of this prolonged study section. And it says, up until 2013. So that was 8 years ago, which is not long in terms of science. Like, people might think 8 years ago, good Lord, we've had, 6 different versions of iPhones and 8 different forms of social media by that time, but I mean, that's not a long time. The only research involving plant protein was with soy. When we're talking about over the course of several weeks of training, there were no training studies that had been done on any other source of protein besides soy up until 2013. So that changed when Jordan Joy, who was with Jacob Wilson when they were at University of Tampa, partnered with a consulting firm in Milwaukee called Increnovo, and they did a study where they compared rice protein to whey protein. And remember, we talked a little bit before about leucine and leucine being important. Well, so rice has a much lower content of leucine. So they delivered, for this study, they gave 48-gram doses. So they gave a really large dose, and that was by design. So they wanted to make sure, basically they're saying, if we make absolutely sure that there's enough protein and enough leucine to promote hypertrophic adaptations to resistance training, are there differences between whey and rice? And they showed that there were no differences. Basically, both groups got stronger, both groups got bigger. Now, obviously, there's some criticisms from that study in the sense that, well, who takes a 48-gram dose? That, it's like that. So that was, but that was by design. I mean, they wanted to kind of rule that out. I think I can kind of plug ourselves here. So we actually followed up with a study where we built upon that rice versus whey question, and we used a 24-gram dose of protein, and that was important because that was literally like the just the minimum threshold for leucine content for rice. So in our eyes, it was just, if there is a theoretical threshold of leucine where it functions like a light switch, where if there's enough there, it switches the protein synthesis pathways on, that we were just going to deliver enough. And then we wanted to see where there are differences between rice and whey. And across 8 weeks in a group.
And what was that leucine content? I'm guessing it's probably around like 1.8 or
something.
Yeah,
1.7, 1.8. I don't know exactly, but I think it was, I think it's around 1.8. And, so across 8 weeks, we saw improvements in strength and hypertrophy in both groups, but again, we didn't see any differences. So now we have 2 studies that show that across 8 weeks, with supplementing with enough protein and enough enough leucine, that there wasn't any measurable differences statistically. Our study was a little bit underpowered. We lost a few more people to some attrition than what we really would have liked. So that side of it was certainly kind of a shortcoming. But I think in general, I will say, and I even tried to highlight this, is that the whey group, the needle was moving a little bit more with our whey protein group, but within our delimitations across 8 weeks, we didn't see any statistical changes. So certainly it remains to be seen if we would have trained for 12 weeks or 16 weeks or added another subject or 2, would we have seen differences? I'm not really sure, but I think, it would, there was a little bit of a difference in terms of kind of fat-free mass accretion. That doesn't mean it won't level off after 10 weeks either. So, but there, so that kind of gives everybody, I think in general, these studies are, like I said, 8, 10, 12 weeks. They're usually following some form of resistance training program, usually, minimum of 2 days a week, upwards of 4 days a week or so. We usually do a 4-day a week program. You're testing upper body strength and lower body strength. You're testing some type of body composition changes. And key things there is you always want to make sure that they're getting enough calories, or getting enough carbohydrate. Getting enough protein, getting enough carbohydrates is important too. But, and that's always a little bit challenging, trying to get good dietary information back from these people. So I think, that when we look at, so if we go before 2013, there was a number of studies that had been done with soy, and in general, the majority of that work just showed that there really wasn't much difference. When we looked at across the training study, there was a couple 6-week studies. The one study that you had highlighted, and we actually made a point of kind of highlighting because it was so different in the sense that it was soy versus whey. So this is Volek and colleagues, but I mean they trained for 9 months. So I mean that's a big difference. It's a huge difference. And in this study, they showed that the whey protein group did significantly lead to kind of greater gains in lean mass. So that definitely creates a kind of an important area of context that, yes, we might really try to, if you're on the plant protein side of things, you might latch on to this outcome that, see, look, it doesn't make any difference. Look at all these studies. And that certainly is absolutely true. Maybe within a 2-3 month window, 4-month window. I don't know how long, it may not make a measurable difference. But there is one study, at least when we compare soy to, kind of across 9 weeks, to show that there were some differences in favor of whey. So I don't really know how to view that, because I think, quite honestly, it's one of those things that, I've never done a 9-month training study. And the colleagues that I worked with, I mean, Rick Ryder's done all kinds of training studies in his day, and he's not really done many 9-month resistance training studies. Some of the weight loss studies we did with him got into that long. Those you're just not going to see a lot of those types of studies appear. So it is a bit of an outlier when you look at just from the study design perspective. So I mean, mad props to Jeff and his group for keeping people in a study for that duration of time. And I think it would merely be speculation to suggest that if we did pea protein or rice protein or would it, if across 6 weeks, would whey protein or casein protein, some animal protein, would it be better? And I don't, it's just speculation, so
Yeah.
go ahead.
Yeah, the Volek study is fascinating. I wasn't previously familiar with it until I was reading your review, and then when I was looking into the Volek study, I mean, it was well powered. The sample size was over 100. They had supervised resistance training sessions, and I was actually looking through the methods, and the resistance training protocol is really interesting. They quote in it, they're like, we didn't want our subjects to just go through the workouts, so they had like this flexible periodized program to make sure that everyone was going all out during these programs. So like I said, good sample size, supervised resistance training, and then we see these differences. And then as you mentioned, it was 9 months long compared to all of these other studies. So it is really thought-provoking. We don't really have anything else to compare to, as you said, but I guess, you wouldn't feel confident to say that like these are just spurious findings, or that, hey, if we had other 9-month studies, I think these results would be replicated. But it sounds like you're just overall unsure. Is that correct?
Well, I mean, I think how I positioned it is, the Volek study across 9 months showed that whey was superior. Mm-hmm. There's, when we look at our study with rice and rice versus whey, and Jordan Joy's study rice versus whey, I can definitely speak to ours. We didn't see any differences across 8 weeks, but that's really why I kind of highlighted the fact that, I mean, our whey protein group was significantly increasing across that time period, where the magnitude of those differences was greater. So if you increase the time upon, if that effect is real and continues to happen across 4.5 times the duration, I mean, 9 months versus 2 months, it certainly does. It does make you think that, yes, there certainly might be a point where whey would be superior, but I mean, we were a bit underpowered, so maybe there was just a couple of people in the whey group that were really just driving that change. In fairness, you can turn the table the other way. Maybe we just really had a couple of kind of non-responders, just a couple of duds in the the rice group. And so you never really, that's why we do the studies. It's we just so I think it certainly would be nice to get some 4-week study or some 4-month studies, some 6-month studies, and different things along those lines. But as I said, they're hard to do. A lot of times, if there's a company sponsoring the study, they really don't want to wait 4 months, 6 months to get the results. They're wanting an ROI on their investment a little bit sooner, or at least some information to let them move forward. So, yeah. So I think overall, bottom line, I mean, it's great work by them.
Now, outside the Volek study, as we mentioned here, you could consider duration to be a limitation to a degree, but another major limitation, one which you guys highlighted in your review that I thought was fantastic, because at least in other reviews that I've seen, I have not seen this point mentioned, and that is, we have all of these quote unquote prolonged training studies looking at, a plant-based protein supplement versus an animal-based protein supplement. And on average, we really don't see any differences when it comes to muscle hypertrophy and size over these intervention periods. However, something that is really important to consider is that the participants are getting a protein supplement, right? This is, usually a 25-gram dose. And in the context of their overall diet, this one serving is maybe 20% of their total daily protein intake. So we have to consider that in the context of a mixed diet, right? Like when I get an athlete and I look through their food journals and I see, oh, they're eating 4 meals per day and total protein intake's pretty good. And I see that like 3 meals are some sort of animal-based protein and then 1 meal is tofu. I don't look at that and go, oh, like this is a suboptimal diet. We need to get that 1 meal with tofu out of the way. So I would just like for you to expand on that limitation and how you think this should influence how we interpret these findings.
Yeah, I mean, for me, I think that that was kind of one of those points with your, I mean, because that's with our own paper. You know what I mean? Like you're just kind of looking at it like, man, we're really trying to provide some good insight into this question here. But, you know, it's like, man, it's like all we're doing is giving a 24 gram dose of rice. So I mean, I think it's, you know, it's a very relevant, it's a relevant point, because I don't really know, as much good as we're trying to do from some of these studies, it's still a little bit of an incomplete answer, because it's truly not rice versus whey. If we have, you know, I mean, you know, because we definitely were not screening in or out omnivores and carnivores, and, you know, like we didn't, that what their diet was like prior to beginning the study was not really a factor for us. So I think in hindsight, that could certainly be an important aspect of a discussion moving forward. Of course, you know, we're going to need more studies to really get at that answer. I mean, a little bit more clearly, but I think, you know, but I mean, really, I mean, quite honestly, beyond what we've provided and what I've kind of talked about, I mean, there's just really not much more to add, in the sense that, you know, like it's out there. And I think, you know, people just need to, you know, kind of, you know, we've highlighted it to force people to think about it. And as a result, if you think, you know, the studies like ours that are only delivering a single dose and, you know, are largely useless in this conversation, then that's, so be it. You know, I mean, I think if there truly are differences, we go back to the acute studies, and the acute studies are informing us that acutely, the same dose of, you know, of animal versus whey is providing a more robust anabolic stimulus. And we're led to believe that that's going to make a difference if promoting MPS is what's going to kind of promote some long-term adaptations. Then I think, yes, if we were able to replace 20% of the diet to 40% of the diet to 60% of the diet and so forth, that there would be, that, you know, at some point it should make a difference. I've seen many times, though, where just because it makes sense logically doesn't mean that it turns out that way. So, you know, that's where, I mean, this plant protein conversation is not going to go away for the next 10 years. I mean, it's just, there's going to be different sources pop up. We're going to start seeing more combinations of plants with different nutrients to help kind of fortify them, to make them a little bit more robust anabolically. There's a number of things that are going to start to, you know, so we'll be investigating plants for quite some time.
Absolutely. And to that point, the second study to highlight here was published very recently by Hevia-Larrain et al. May or may not be how you pronounce that.
Right.
But anyway, in this study, we were basically looking at a vegan group compared to an omnivorous group. And I believe based on the background characteristics of the participants, everyone was following these diets for at least a year prior to the study. And then within the study, they more or less equated for total protein intake between groups at 1.6 grams per kg per day, and then had them on a 2-day per week resistance training program. And they saw that after, I think it was a 12-week period, that there were no differences in muscle hypertrophy and strength between groups. And I've seen a number of my vegan peers, strong advocates of vegan diets, sharing this study, especially since, you know, there is some hyperbole out there in regard to, you know, the impact of a vegan diet on muscle and strength and how it could be suboptimal. But basically sharing these findings and saying that, like, see, you know, in case everyone was wondering if these criticisms were wrong, they are definitely wrong. But when we look at the finer details of this paper, we see that these subjects were not resistance trained, which is a big red flag to me when we consider just how powerful the stimulus of resistance training is, especially when you're a complete noob to the procedures. So I'm just really curious to hear your take and what we can make of these findings, if anything, because of that pretty big confounding variable within the equation.
Yeah, and I mean, training status is a very important variable. We've seen a number of, one of the metas that we refer to, Naomi Cermak published it, and they did a really nice job, produced a forest plot where compared, kind of basically trained versus untrained, and showed that, there's some subtle differences in some of the outcomes within, strength or hypertrophy, fat free mass in this instance. So, so there, I mean, I like how you mentioned the fact that, I mean, it's for a relatively naive individual. I mean, adding in a resistance stimulus is a huge systemic, widespread physiological response. I mean, is gonna take place. So I think that the magnitude of that response certainly does kind of level off, if you will, as people start to become a little bit more accustomed to the training. And it still happens. I mean, you still see a very robust responses, but it does get a little bit less magnificent as people go from an untrained state to a trained state. So there is that to keep in mind. I mean, I think in some respects, I guess you can always play devil's advocate in the sense that, I mean, both groups, right, were relatively naive. Both groups, but so the biggest advantage for this study gets at the fact that it helps to provide some clarity to our previous conversation with, a study like ours where we're only delivering about 20% of, 20% of total protein intake as a plant source versus an animal source, whereas these people were, living that way, so that, all of their food intake was coming from plants or coming from animals, 12-week period of time. They had their protein intake at certainly at an appropriate level of 1.6. All those things are very, very good. There's no other kind of, glaring weaknesses, I guess, if you will. So it would be, so I mean, your point is extremely well taken. I think it's absolutely something to highlight and to make sure that people understand that, these outcomes, they are what they are, and but they are in a relatively untrained population. So if you're talking about, taking the plant versus animal discussion in a trained population, would the results be exactly the same? Would they be different? I mean, those are just impossible questions to answer. I don't. I think in general, from what I've been seeing though from the literature, I mean, I think there'd be a pretty strong nod to think that there likely wouldn't be much of a difference. That's just my gut. I don't. Because I just feel like, even as we get more and more trained and our muscle metabolism and everything else adapts in the manners that it does, as long as you're delivering enough protein and enough aminos, I mean, I generally think that's the strongest message, that's the strongest signal that we keep getting from these outcomes, is that if there's an appropriate amount, the body doesn't really separate itself, whether it's coming from animals or coming from plants. If there's enough, so I think that's probably where I would shine the light, is just, hey, let's not worry about, would it make a difference in trained or an untrained. It's just more of the fact that we're consistently seeing that if there's enough there, that the differences are relatively minor, and so I think you should take that going into it with a trained population, and then if that doesn't hold up, it doesn't hold up. That's why it's always fun. It's always fun when these types of studies get out there, because it if you rely upon the literature to base how you go about communicating things, it changes your discussion. It changes what you have to mention, and I've always kind of had a lot of enjoyment in that, because you learn it as you go.
I don't want to put, all of my stock into one study, because that's never how we should evaluate the research. But bringing up that Volek study again, it is interesting that it was 9 months, because also the subjects in this study were untrained. And we could probably at least argue that over a 9-month period, at some point within this intervention period, those quote unquote noob gains were probably being controlled for to some degree. Whereas, in a 12-week study, as we mentioned, you could argue that, throughout the entire course of that in an untrained population, like, these results were probably heavily influenced by the resistance training stimulus compared to the protein sources being consumed. Now, you mentioned there the ultimate thing here is getting enough of these amino acids, which brings me to a question which might be one of those impossible questions to answer, but I would just love to hear your hypothesis here. And that is, when it comes to getting enough, might there be a reason to think that enough, quote unquote, means a higher total amount of plant-based protein if your diet is exclusively plants compared to animal-based proteins? So to give you an example here, like, if we reran this study, vegans and omnivores, but we did it in a highly trained population, and we consider, that Morton review showing that we needed at least 1.6 grams per kg per day to maximize these body composition outcomes. Do you think it could make a difference in a highly trained population, whereas 1.6 predominantly coming from animal-based sources is enough, but if it was exclusively plants, then maybe it could be more like something like 2.0 grams per kg to get similar results? Or do you think still in this equation, it probably just levels out at the same total intake?
I for me, I think as long as people are getting enough, I don't really think that the amount is, I think the actual amount takes a back seat as long as they're getting enough. And then I also think, even from like the training status side of things, if they're getting enough, I think that, those details somewhat become less important as well too. I didn't say they're not important; they just become less important. So, so that's how I'd approach that.
Alrighty. Now let's get into older adults real quick before we wrap this thing up, because that could be the most interesting population in this equation. Mm-hmm. So you mentioned a fascinating study earlier looking at the MPS response to 40 grams of soy in an elderly population, and we didn't see at least statistically significant increases in MPS from baseline, which brings up the question, right? So if we settle on these ideas here, that when we're looking at relatively young, healthy, trained people, it's just about getting enough, and there isn't really any limitations for how they can get enough. This brings us to older adults who do have a very limited appetite, and where we might need to be more careful with the choices we're considering, especially when it comes to preventing or delaying these age-related losses in skeletal muscle mass and strength. So, which brings us to this general question for you. Do you think that the quality of protein sources might be more important in this particular population?
So I mean, there's several areas of just rationale and logic toward the answer to your question is yes, that it might make a little bit more of a difference there. And you highlighted several of them. And I think one of the ones that we had talked about when I kind of get into that other study is, with aging, right, we see this anabolic resistance that develops, which means that we we need to deliver more leucine is what I think that people feel like is the answer. So how do you do that? Well, you can deliver an animal protein that has higher amounts of leucine. You can deliver more of a plant protein. And then also, but there, so if there's reasons why somebody doesn't want to consume an animal protein, whether if it's cultural reasons, planet sustainability reasons, if there's some health complication that comes with, particularly if we're talking about animal proteins and the sources of foods, versus isolated powdered proteins. So maybe an older individual doesn't want to eat a steak, because of appetite related reasons, doesn't want to eat, so you have to just think about all those different scenarios and reasons. And that's where, the plant proteins for some might have a level of attraction kind of within them. So I think that it'll be important for us to begin to kind of explore that question a little bit more, to be very candid. I mean, we absolutely don't have enough literature surrounding it. There's been some studies that have been done. Tim Ziegenfuss's group, in partnership with Nutrition 21, has published, some results showing that they've got a kind of a combination of nutrients that they feel like helps to potentiate the MPS response. Stu Phillips's group did a really neat study where they gave like a dose of like 6.25 grams of whey, but they matched the amount of total leucine in that 6.25 gram dose. So they basically fortified it with more leucine to where they delivered the same amount of leucine that's in a 25 gram dose of whey, and showed, and there's a lot of things that kind of, the responses aren't identical. There's still some areas where things are a little bit more favorable, but there's some of these ideas, these areas of innovation where the bottom line is that you can deliver a lower dose. So what does that speak to? That speaks to an older person's lack of a general interest in food and appetite. And that's just why they may not want to eat larger meals and everything else. So, so ways to help to potentiate that MPS response within a plant protein. I think personally, I think we're going to see a lot of innovation in that area in the next, it's probably happening now, because I'm usually not that smart and kind of get out in front of it. So I would say in the next 2 to 4 years, we'll probably start to see, just kind of more of those studies start to appear that are getting at this scenario of, well, for example, you take our study, of 24 grams of rice versus 24 grams of whey, and do it in an older population. And I would not be surprised in the least if rice did not do as good as whey. I would not be surprised. I think there'd be a lot of people who would not be surprised. So you just look at it for that 24 gram dose from a marketing standpoint, what's commonly delivered, like that's kind of a standard dose. That's what the scoop size is. That's what, okay, well, if, you can't just tell an older person, well, just take 2 scoops. Because they're just like, well, no, then it gets really thick and I don't like the texture and it doesn't taste good. And it's, it's like, well, then mix it with more water. Well, I don't want, you know what I mean? Like, it's just, so like these problems start to pop up. So that's where, okay, well, how do we stay at that lower dose and how do we make it better? How do we, and I think we're going to see some innovation in that area because, the aging population and sarcopenia, and those types of things, there's a whole lot of people and a whole lot of zeros in forms of dollars with managing healthcare and making, as people age, helping to improve how they're aging, to improve their quality of life, so there's a lot of reason why companies would be interested in that. They just have to want to market to that population. Some sport nutrition companies just want to go after, the young and the fit and the athletes. So, so I think that will be a really interesting area of discussion. Quite honestly, we don't have enough studies even on animal proteins with older individuals, so But even you think of, take somebody like Darren Candell up in Canada, who's done a lot of work with creatine and elderly individuals and bone health, and I mean, adding creatine to a plant protein, like that's just, like that, is that an area for older individuals, for any individual, I mean, yes. So there's, like I said, there's just all kinds of things we can kind of throw out there.
Yeah, absolutely. Like I believe in that Hallmark review from Moore. He basically, he might have been the first one to put us out. I'm not sure. You can correct me if I'm wrong. But basically put out there, in terms of maximizing the MPS response, when it comes to these younger healthy individuals, 0.25 grams per kg for a serving of protein will get the job done. Whereas it's probably at a minimum 0.4 grams per kg in an older adult, and even upwards of 0.55 depending on the source might be necessary. But yeah, it's a really interesting area, especially if leucine in particular, which it definitely plays a large role to a degree, but if that's the calling card, that can make a huge difference, right? Because when we look at like 100-gram serving of like dairy or beef or something, you're going to get that minimum floor for leucine at around like 1.82 grams. Whereas as far as I'm familiar with, when it comes to like varieties of beans in a 100-gram serving, it's more like 0.5 to 0.6 grams. So if we're trying to get that leucine trigger at around 2 grams and you need at least 300 grams of beans just to meet that, I mean, that has a huge effect on appetite, which, can be a big issue in that population.
Yeah, and the thing we always try to extend what you just said there. Those are great facts for people to just kind of begin to think about and process. And you're just like, I mean, I don't even know how much 300 grams of beans is,
Yeah.
but it's just, but some people may think, oh, well, I like beans, like I won't mind it. But I would commonly say, but do you want to do that every day, or do you want to do that every day for multiple meals? You know what I mean? And then it's just like, and many people don't. So like, even you go back to your numbers of that, 0.25 grams per kg per dose, and then older individuals up to 0.4 and maybe even higher. Like in that discussion, those recommendations are framed within an animal source of protein, right? Correct me if I'm wrong.
Yeah,
So
absolutely.
now what do those numbers transition into if we're talking about an animal source of protein or a plant source of protein, excuse me? So then you just have to recognize the fact that, and we certainly mentioned that in our review, but then, it's been known for years that appetite and it goes down as people get older. So you have these things working against, those things aren't working for older individuals to consume consume plant proteins as their primary source of protein to promote and sustain muscle mass and so forth. So that's what I mean. Those are definite areas of research and innovation, and where science can help, can make an impact.
Definitely.
Mm-hmm.
All right, Dr. Kerksick, that is all I have for you today. Thanks
Great.
so much for your time. I really appreciate it. For the listeners who want to learn more about you and support your work, where can we point them towards?
Yeah, so I'm not a social media guru, but I will. I mean, I'll kind of Instagram at Chad Kerksick, Twitter is at Chad Kerksick, so KERKSICK, and then the other thing that I really wanted to mention. So I'm one of so I direct the Exercise and Performance Nutrition Laboratory at Lindenwood University. So we're regularly doing kind of clinical studies. Obviously, we recruit participants from the predominantly from the St. Louis area, but we're working within our university to kind of to create more like a web-based presence for the lab, to just be a resource for studies and podcast appearances and different things along those lines and whatnot. And then the other thing is I'm one of the vice presidents of the International Society of Sport Nutrition. So the ISSN is it's the only professional organization we have out there that's just geared towards basically the kind of professional development of sport nutrition. So if you like this stuff, you like this area, it's a great organization, I think, for people to get involved with. Obviously, you were at our recent meeting. I think we've done a really nice job with some different position stands and some just help to try to stay at the front of the literature. So definitely, if some listeners are not familiar with ISSN and everything else, definitely look us up along those lines and then consider kind of reading some of our journals or coming to a conference or something along those lines. So
I will link up those resources in the show notes. And as Dr. Kerksick mentioned there, this year was my first ISSN annual conference, and
cool.
I can't recommend it enough. It's a group of wonderful people, all very inviting. And of course, throughout the weekend, you got to sit there and learn from the leading experts in the sports nutrition field. And if this is a topic that you are particularly interested in, there's nowhere else to go. Check out the ISM position stand papers, become a member, maybe become a certified sports nutritionist through their organization. I can't recommend it enough. But everyone, that does it for another episode of the Muscle Memoirs podcast. Thank you so much for tuning in.